Yeah, hello. So in our last video, I think I wrapped it with my weather application project, and by the way, look at it, I got 6 likes for it. Yeah, later I think that they changed the tutorial API to visual crossing, but mine still uses the weather API and it works completely fine for me. Yeah. Yeah, so that's it about that. And I think that I did my last video about weather app in the end of May, and for June, and in June I had exams, so I didn't do. Yeah, I think before exam I completed till link list or something. Then yeah, then July my exams ended and I was quite busy. So yeah, so I couldn't pass this up. And yesterday I also had a lab exam, and yeah, my exams are finished for now. And yeah, and today I completed it. Today I completed all of this bit of computer science. This module basically they are trying to teach us the fundamentals of computer science, and I think it's great because so many Udemy courses and um, things like that forgot to like they don't mention it, but I think those are important. Yeah, basically recursion. Yeah, the reason that I didn't make videos on individual on each of these individual projects was because like there were quite small projects, like most of them were like 100 lines, and there wasn't any UI, so I thought that there wasn't any reason for me to do it. For recursion it was quite easy. I had done merge sort before, so it was quite easy for me. Also the Fibonacci was a piece of cake. Yeah, it's just 34 lines here. And for English it was also easy because since it's a linear data structure, it was quite easy to wrap my head around it. Like yeah, I also implemented it in C++ before. Like I had done things related to linked list in C++ during my college sem. So linked list was also easy. Hash map, I haven't done anything with hash map, but this was also quite easy because they explained it well here, and the project was also quite easy, and it's also a linear data structure, right? And it mix of linked list and array, and both of them we have used before. So it was kind of easy, like it was so easy to do that. I think I also did this hash set as well. Let me just check it. Yes, I also did hash set. Those were quite easy. Hash map. Then the thing that tripped me off, like I just spent my entire week for this. I couldn't understand anything that they gave here. Like, why didn't they give like for linguist? Yeah, for linguist they have haven't they? No, here I think they have given at least some like explanation here, structure of linked list and things like that. And for hash map they have given an entire chapter for it. But what about binary search trees? Like this isn't a linear structure like the others, and it's so hard to build. And the only thing that gave is a link to a geeks for geeks article, and I don't think I have to mention about geeks for geeks article. I would never trust on those. Yeah, it was kind of hard for me. I think they should have added in some more small things. Yeah, like at first I got tired and I used ChatGPT. Then I regretted it later. Then I again started again, but then again I just got tired and used ChatGPT. Then I did was I like blocked the ChatGPT from my router. Like I blocked the ISP, the DNS for the ChatGPT, and now it's not even opening. Not DNS. I just blocked it from my router. Yeah, also the Gemini as well. It won't open up. so that I won't copy from ChatGPT. Yeah, it wasn't quite hard like delete. No, I wouldn't say delete was hard. It was after like learning, after seeing the algorithm for 2 times, deletion was easy. All this were easy. Level order it's easy. I have done it before using Q. These I have also done before. These were the things that threw me off. The rebalance was also easy. It's just using the already existing build tree and using this in order function to get the sorted array. Like the in order function will give us the sorted iteration of a binary search tree. So yeah, just using I know it before, so I just used it with build tree function, so it was also easy. These three were the things that threw me off. Height was okay, since as height was okay, it was just 2 lines of code. After googling and yeah, I just found out about it. These two were the things that threw me off, like depth. Like for root sorry, for height we go from the root to the leaf, right? So there's a connection from root to the child, but for depth we go from child to the parent, right? There's no relation from a child to parent, like there's no way to directly access it. So it threw me off, and yeah, and I didn't understand any of the articles. Like there were very many articles, so finally I just yeah, I'm doing, yeah, by the way, I'm doing neat code every day. Like I try to solve a problem every day. Yeah, uh, yeah, I didn't do it every day, but I try my best to do it every day. But I don't have enough time for that. Since I also have to do my mini projects and other college university projects. So yeah, but I still try my best. uh, yeah, yeah, it's a good thing to do. Yeah, yeah, after completing Odin Project, yeah, we will not get enough time for that. We have to cram the DSHF. So I just started it before. Yeah, so basically for the depth, neat code, just search neat code depth. He had made a good video on it, and I studied through this video. Yeah, so that's how I did that. And as for ease balance, he has also made a video on ease balance like this. So I watched those videos to get an understanding of this. I wouldn't say that even in my third iteration of doing this, I completely understand it. Like I can yeah, for the rest of those hash map, linked list, what else was the recursion, I'm 99% sure that I would be able to pull it off if they just gave me blank paper. But no, this wouldn't, like I wouldn't be able to do this. But at the end of the day, I think that what they really wanted to teach us was the traversing method, like the BFS and DFS, because they have given priority for it here, and they are also having like linked any resources for these. So I think the level order, which is basically BFS, and yeah, there's another reason, because in JavaScript, here also they mentioned that now you are pro with DFS and BFS. So I think that they just put those height and depth for the completion, for the sake of completion of that BST. Yeah, whatever. I think they need to, at the end of this, I will just I will write, yeah, I will write in feedback that they should improve the binary search tree curriculum for chapter. As for this, like the other project took me 7 days. Like it took me so much time. Yeah, excuse me out. But for this, like I just did it morning within 45 minutes. It was so easy for me. Like, I don't know if it's because I've done graphs before, but it was so easy, and it's like only a basically just a function. What is it like? Sorry, not me. Just a 55 line function. I don't know why they put it the end of this bit of computer science module, but anyway, this was the easiest. Like, yeah, this was the easiest since I said the shortest path. I knew that I had to use BFS. Like, they also given DFS and BFS as a hint here. So for DFS, since it goes in depth wise, like, I don't know, it would give us the better solution, the shortest solution first. I don't think so. In BFS, since it visits the adjacent, if it's the since it visits the all the nodes that are adjacent to the current node, yeah, it's the fact that in BFS the shortest path will be given first. So yeah, so I know that it's BFS. For graph representation, I use parchment. Sorry, I used yeah. Sometimes when I speak English, I am a Malayalam native. Like, I am from Kerala, India. Sometimes I mix my Malayalam with English. Sorry, I'm trying to improve. Yeah. So basically, it's what was it? Yes, it's adjacency matrix. Like, we didn't use adjacency matrix, but it's a basically a similar concept, right? Well, whatever, I don't know. I have done adjacency matrix before, and it's also given here section on representing graphs. Yeah, yeah. Here also they have in the Odin project having written any explanation on their own. They are just linked to other resources, but it's okay. For the assignment, like, yeah, I will show the code right now. Where is it? Just Knight. So basically, this is the function. I just get start and end. The board size is 8, and if the start or end isn't in a range, like if it isn't in the indices between 0 or 7, I throw error, and I catch that error here in this pretty print function. I just try to incorporate like modern JavaScript features, so that's it. And if that isn't the case, there's some possible moves. Like, these moves are basically yeah, there's basically the moves that the what is it, yeah, this basic move is to 2 step forward, like 2 step forward here, and 1 step side. Like, this is 2 step forward and 1 step side. And yeah, I just there's 8 possible movements, like 1 2 3 4 5 6 7 8. And like, for this 1 minus 2, 1 row plus 1 row, that is, this is the row axis, is in the column axis, right? So currently it's in 3, so we just increment row 4 to it's 4 now. Oh, sorry, it's the, this is the row indices, row axis, and this is the column axis. So currently it's 3, then we increment it by, like, here we just add it by, what is it, 1, so we add it by 4, add it by 1, and it's 4 right now, and minus 2, like, now it's here, right? And this is the column axis, and we add minus 2, like, what is 3 plus minus 2? It's basically 1, so it's one possible move. And 1 2, that is 1 here, and 2 here, and then 2 minus 1, that is 2 here, minus 1 2 1. Yeah, so these are the possible 8 moves, and I used a set to take note of the visited nodes. Like, I think if you don't use a set, then it would probably make a infinite loop if the graph is undirected, and if any of the node, that is, if any of the vertices degree is more than 1, I would assume. Yeah, anyway, I don't know, anyway we need to use a set or array, whatever we want to use, since I saw many using set, and it's also the way that taught in my school, so I use the set. And for queue, and then we just do the BFS algorithm. We use a queue. This isn't an actual queue, this is array. We mimic it by using, we mimic a queue by using the shift and push method, push for DQ, sorry, push for NQ and shift for DQ. It isn't very optimal, but for this case it would be okay. Yeah, and I represent each vertices as an object with two components, like a vertex which basically contains the vertex coordinates, like 3 3, like currently 3 3, and it's that, and path, like, and the path, if it's the start, then the path is null. Null means there's it's empty, because yeah, if the end is given as well, then if the end is also the start, then we don't have to move. So yeah, so that's why it's like that. And till q is empty, what we do is we shift, and if the vertex, the shifted vertex is equal to the end given in the function, then we return then we just push the final vertex and just return the path, then that's it. Otherwise, for each of these possible moves, we add to the current vertex, and we take a next move for each of those 8 possible moves. Okay, and then we just, and if the next move is out of bound, like if there's any minus values or anything greater than 7, then we just continue this, like we ignore that move, and we continues used to skip one iteration. And if we also find that if the vertex is already visited once, like if the set has that vertex, then we also skip that iteration. Sorry, if that isn't the case, then we add that specific vertex node to the set. Like we use JSON stringify to store it as a string, because if you try to store just basically if you try to store like this, it won't work, because in JavaScript the arrays are not passed by values, it's passed by reference. So like these are in same, like these are in same. Yeah, this just creates a new entire array, and its reference is different, so it won't work. So we need to convert it to string first, and we save it in the set, and later we push it to the queue. So that's basically it. We add that next move vertex, and we append the current vertex to the current path, like the path of the current vertex plus the current vertex itself gives the path of the next move. Yeah, so that's basically it, and we just continue it till we found a possible path here. If it founds, then we return, else if none found, then we return false, return null. So that's basically for the Knight Travails function, Knight move function. Then I just incorporated a print function to print it, like I will show it right now. Yeah, just to print it. Here I also incorporated try and catch. If this is the one that if this block executes, then it will throw an error and it will be code here. And code here, is that the right word? Isn't code passed? Yeah, I don't know. Basically we try to catch it here, and if it's an error, then we will console log the message of that error. Else yeah, basically const result, we just store the path in the result variable, and if the result is null, we return and console log that we can't see any path. But that, yeah, it's something that Odin never execute, because they clearly said that given enough turns and knight on a standard 8 chessboard can move from any square to other square. So it wasn't really it wasn't anything useful, but yeah, still whatever, just for the sake of completeness. And yeah, then we return. If that's not the case, then we console log the length of this, that is the possible, that is the, sorry, that is the number of movements. And you have the trick, like if the movement is, if the number of movement is 1, then I output move, otherwise it moves. Yeah, here see, yeah, one move, here one move, two moves. Yeah, yeah. And then now I loop through the two-dimensional array and print out each path. Yeah, so that's basically for my Knight Travails solution. It was the easiest, I would say it was the easiest out of all of them in the bit of computer science. Yeah, except for the recursion, of course. Yeah, but yeah, I think it's even simpler than recursion. Yeah, well, whatever. I come to the solution, and yeah, it's completed right now. Completed now. Now it's deeper look to Git. I plan to complete these two before the end of August. Yeah, I would say I would try to complete them before the third week of August. Then I would start. I will try my best to start React before September, and I would yeah, I would try to complete React. React only has 3 projects. Why? JavaScript has 12 projects. Yeah, I think it's not in depth, but whatever. I will try to complete it before, as I said, before the end of September. Then databases is easy. I done many projects with MySQL, Postgres. I've done various courses as well. It was also covered in my college, so it wouldn't take much time out of me. Node.js, I think September, October, I would try to complete databases and Node.js together. But since it has 9 projects, I don't think would it be possible to complete it within 1 month? I don't know, but anyway, before December, like before the end of the December, I will try my best to complete all these. I've been trying to complete the Odin project for the last 3 years, but this year, this is my final year of college, and I'm so afraid of what will happen next year. So I just took the extra mile, and I'm trying to do it. Yeah, I'm trying to do it as the best. Like, yeah. So that's it for my video, and thank you for watching. Like, I will see you soon.